Hello, my name is Gabriel.
Hi everyone, my name is Shannon.
So we're going to be talking about number pads today.
Next slide.
So what are they? Number pads are a counting model. Each number is represented within a triangle and a rectangle, and the rectangles can be clearly counted. So this is a visual representation of it. So it counts from 1 to 10, and so each block represents a specific unit. But when you combine them, you obviously see the pattern of counting by tens, and then it becomes a little bit more intricate. So you begin to start counting by tens and hundreds and thousands, and so it's just a really visual representation of cardinality, which is an idea that we'll get into in just a bit. But another kind of important little side note: number pads provide a more supportive model of numbers, which is important as we want to models that consistently help students build confidence and accurately solve problems. So this is something that I just touched upon briefly. So cardinality. So I'll read the definitions and then get a little bit more in depth. So a one-to-one correspondence, students can connect one number with one object and then count them with understanding. So a visual representation of this is counting these balloons, and then the one-to-one correspondence would be like, how many balloons do you count? But the idea of cardinality is that the last number that you've counted, it represents how many you have as a whole. So if you're counting 9, balloons, and that means 9 represents the amount of balloons that you've just counted. It doesn't represent each number that you count isn't on its own. It's rather this collective idea. What it looks like. And so for unifix cubes are a great example of how model pads work and function. And so here we have single units, and they begin to become like stacked upon. And so this is like a good way for students to kind of like manipulate number pads. And then these are the patterns that I started to explain early on. So here you have rows of 10, and those rows of 10 become 100, and then you kind of can create like 1,000 blocks with them. But now we're going to go over some concrete, semi-concrete, and abstract ideas in the CSA sequence overview.
Ready. All right, everybody. So some of the concrete manipulatives are unifix cubes, role-playing, and singing. And just to give you a brief definition of what concrete, semi-concrete, and abstract are, concrete is more of a hands-on, a kinesthetic type of thing. Semi-concrete are visuals and almost like manipulators for the abstract of numbers, and then abstracts are like tallies. They're more of like a 3D form. They're not really like a hands-on or like a visual form, but it's almost as a the tally marks, the plus signs that you see in next visual. Okay. Next visual. So an example of a semi-concrete are drawing arrays, tally marks. So these are just a few things that explain what a semi-concrete is. It's more of a visual and like an abstract put together because you can see it and you can kind of put it there yourself. And it's not the normal, your normal 1, 2, and 3 numbers. You can use different materialistic things. Slide. And this is abstract. So abstracts are numbers and equations, but as well as you see, they are the plus sign, the minus sign in a creative, artistic form that's more entertaining and more fun for our students to understand and learn a little more. So 1 plus 2, you do 1 plus the big, 1 and the big plus sign, and the 2 equals 3. Example. This is just a engager that we created for you all. It's a link that'll help you and give you some tools and resources that'll give you some more insight on number paths. And then down below, we have 1 through 5. We have just some numbers that explain what number paths are. As you can see, can you show me 2 plus 5 is equal to 7? And your number chart goes all the way to 1 through 10, but you're gonna cross out 1 through 7.